Hi, today I'm going to discuss current sensing, what current sensing is, and some of its applications in a laptop circuit. Now, in the previous video, I discussed data lines, how a pull-up resistor creates a data line, how the fact that a pull-up resistor creates a line that's high allows other components to short it to ground to create pulsing. I showed you what the pulsing is, and I showed you the different types of pulsing when a battery was and wasn't connected, and I showed you how the system management controller can communicate with a battery and a battery charging chip. Now, what is it that they're always talking about? This is one of the things that is going to be the next question. What is the battery charger actually telling the SMC? What is the battery telling the SMC? In addition to just telling it how much battery is left, aren't you interested in how long your battery is going to last? You know how it says, oh, you have 6 hours of battery remaining, but then when you start encoding video and put your brightness all the way up and have your speakers playing, it says you only have 1 hour left? How do you think it knows that? How do you think it actually knows how much power your system is using? Well, the way it knows how much power your system is using is through a current sensing circuit. And today I'm going to discuss how the current sensing circuit works and how it sends information back to the system management controller so that your computer has an idea of how long it's going to be allowed to stay on for. Let me just go over to the schematic over here. Now, here's the way measuring current works. You have to be inside the circuit and actually feeling the current flow through. Voltage is the potential difference, whereas the current is the actual power. That's the actual current moving through. In order to measure current, you have to be in the circuit. So here, this is current sensing for the charger. So this is a great place to measure current from the machine because you're directly measuring the power that's leaving the charger and going to the main rail of the computer. So here's how this works. This is a really, really low impedance resistor, 0.02 ohms. That is a very, very, very low resistance resistor. It's not going to have a lot of effect on the machine, but what it will have is a voltage drop across it. Now, the thing with the proper current sensing shunt resistor, the thing with this resistor is that that resistor is going to have a voltage drop across it that is directly proportional to the amperage being used by the computer. Let me repeat that. The voltage drop from this end of the resistor to this end of the resistor is going to be directly proportional to the amount of amperage going through the resistor. Knowing this, we can then compare that voltage drop. Knowing this, we can then match different levels of voltage drop across that resistor with different amounts of amperage being used by the machine, and then we can tell the SMC to calculate how much battery power we have left, or how long it's going to take to charge the battery, or whether or not my charger is using too much power. Again, let's say it thinks my charger is trying to use 7 or 8 or 9 amps. It may turn the charging circuit off so the computer doesn't go on fire, and this is one of the things that this chip talks about to the SMC. So over here you have a data line. Over here it says SM bus charger SDA and SM bus charger SCL. That's a clock and a data line going to the SMC. And one of the things this talks to the SMC about is how much power, how much amperage the battery is using across this current sensing resistor, and how much amperage the charger is using across this current sensing resistor. So understanding how current sensing works and understanding this can also help you understand some other problems. For example, it will only charge my computer when it's turned off. It won't charge my computer when it's turned on. Maybe because of a malfunction in the current sensing circuit. For example, let's say, over here, from each side of this current sensing resistor, you have a 10 ohm resistor going to the U7000. For example, let's say that one of these resistors dies. Now, because that resistor dies, it reads nothing from one of the ends of this resistor. So it's going to think that there's a huge difference in voltage, which means it thinks it's using infinite amperage, which means, oh my God, I'm using too much power. Let me turn off the charger, when the computer is, let's say, on and using more power than it thinks it should be. Understanding how this works can help you understand certain problems. For example, the computer thinks my battery is going to last for 2 minutes, even though it's 98%. My computer thinks my battery is going to last for 50 hours, even though it's at 1%. My computer won't turn on off of the battery. My computer won't charge the battery. A lot of these are related to current sensing issues, and this is a very common area to get damaged in liquid damage in laptops. Now, you don't only have to have current sensing over here. You can have current sensing for many different parts of the machine. They have current sensing for the backlight circuit. Some machines have current sensing for the CPU. Some, and you can have current sensing outside of laptop motherboards. There are tons of circuits that use this type of direct inline current sensing, and it's very, very basic. Again, you cannot measure, this chip cannot measure current because it's outside the circuit. It can only measure voltage. So what we do is we put a resistor whose drop in voltage is known for any given amperage that's going through it, and then we measure the voltage difference. Since we know how much amperage the system is using when there's a certain voltage drop across the resistor, when we measure that voltage drop across the resistor, if we tell U7000 or we tell the SMC, when you see this much voltage difference, we're using this much amperage. When you see this much voltage difference, we're using 5 amps. When you see this much voltage difference, we're using 6 amps. When you see, let's say, when you see 50 millivolt voltage difference across there, we're using 1 amp. When you see 75 millivolt voltage difference, we're using 2 amps. When you see 100 millivolt voltage difference across that resistor, we're using 3 amps. If you program it with that information, all you have to do is tell that chip that for these predefined values of voltage difference, here's how much amperage the chip is using. You can pretty much tell how much amperage the system is using based on those voltage differences. And that is one of the tricky ways that we figure out how much amperage the system is using so that we can tell you, here's how much time you have left to use your laptop. Here's how long it's going to take to charge your battery. Oh, we noticed that your charger is using too much amperage. Let me turn off your charger so your computer doesn't explode. These are some of the many useful functions that your system management controller and your ISL 6259 serve inside of your laptop, and this is how they do them. So current sensing is something that you should be able to spot. Again, just like I said, I want you to be able to spot a buck converter over here. I want you to be able to spot a current sensing circuit over here. So you have really, really low resistance resistor in a spot where there's a lot of power that's going to be going through it for a very important part of the circuit. And you have a chip that's reading the top and the bottom of that resistor. This is something that's important to know. It's something that you're going to run into, and it's something that's worth explaining in this video.